Welcome to the first video in a series of videos for the TExES exam 4 to 8 mathematics. This is competency 1. In this competency, a teacher understands the structure of number systems. This competency is part of domain 1, which is 16% of your test. In this video, we will work with properties of real numbers. Before we begin, let's discuss the real number system. And if you aren't familiar with the real number system, I recommend that you go watch some videos and gain a little more comfort with working with them. One thing I do need to note is the natural numbers. We consider the numbers what we call counting numbers when we're working with our students at the secondary level. However, at the post-secondary level, there is a controversy about what constitutes a natural number. In some cases, the natural numbers must include 0, but for the purposes of our students and their testing, that is not a fact. In this case, when we include 0, we call it the whole numbers. And of course, then we have the integers, and then encompassing all three of those would be the rational numbers, which includes the following examples: integers, fractions, terminating decimals, non-terminating decimals with repeating patterns. And there are examples of all these things, all these numbers and values. Okay, and then we move on to the irrational numbers. Now, those are denoted in a couple of ways. There is some standard notation. In number theory, I've seen for the most part would be the R minus the Q. That's what the backslash indicates. That is subtracting out. Okay, that's what that notation means. And then they give some examples of what an irrational value would be. Make note of those before we move on. For these videos, I will use the TI-30XB multi-view calculator. Now that is presentation-wise the same as the TI-30XB and some of the other family of calculators. Actually, I do believe the only calculator that won't give you the similar functions in presentation would be the TI-34. That one will not be used in the videos. I may bounce back and forth from the TExES, X Pro, and so forth. But I kind of like the look of the TI-30XB. Okay, let's look at number 1. The Venn diagram shows the relationship between the particular number sets. Okay, here is the basic diagram of how we look at the real numbers. The natural numbers is a subset of the whole numbers, and then the whole numbers are a subset of integers, and then the integers are a subset of the rational numbers, okay? And notice the irrational numbers are a subset on their own, and they're only a subset of the real numbers, okay? Right. Now, our question says, where should negative square root of 225 be placed on the Venn diagram? Well, what we need to do is pop that in the calculator and then see what that means with our rules, what constitutes each of these subsets. Okay, all right, so let's say push negative first. Negative, and then second, and then we need that square root, which is just above x to the second power. Okay, now we enter 225. Push enter. Notice that's an integer. How do I know it's an integer? It's an integer because, 1, it's negative, okay? And we know that that will not include, that can't be a natural number alone. It can't be in that subset. Well, it can't be in the subset of whole numbers because those two sets are very similar. Okay. Now it's negative and it is a whole number. So the next step up is integers. And we do know what integers are. Well, it's not a rational number in this form. What happened is they divided by 2. Well, that's not what square root means. So this violates a definition. And then integers are what we're saying it is. But irrational, well, that also violates a definition. Even if they make this mistake, it's, oh, look at that. I really honestly did not mean for that heart to go there. Probably shouldn't leave it. Technology. Okay, there we go. Okay. So in this situation, they're incorrect for a couple reasons. One, negative 112.5. That is terminating. It terminates at a half, meaning it stops. That violates the definition of irrational number. An irrational decimal goes on continuously, and we don't know where it stops. Okay, now let's look at D. D says it's a whole number. Well, this is an incorrect calculation, so that violates the calculation and it excludes this negative that was out in front of the square root of 225. So that is verified. B is our option. Number 2, which diagram best represents relationship among integers, rational numbers, and whole numbers? Now, if you remember what was discussed prior, whole numbers are a subset, meaning they're within our rational numbers, okay? So if we look at A and B, in A and B, they're showing, for example, A says whole numbers are not a subset of integers, and integers are not a subset of whole numbers. Well, either way, that's incorrect. We need whole numbers to be a subset of integers. So A does not meet that definition. Okay, B, same situation, and well, integers are a subset of rationals. They are not, say, equivalent to each other or separate. Disjoint is what we see here. That's not the case. And whole numbers, they're a subset of integers. Integers are not a subset of whole numbers. And again, rational numbers are not a subset of whole numbers. So B will be incorrect. Let's look at C. They have integers as a subset of rational numbers. Well, they are. However, you cannot say that rationals are a subset of whole numbers. That this simple fact right here is incorrect. So let's cross our fingers and hope D is correct. Let's see here. It is saying, D is saying, whole numbers are a subset of integers. I agree with that. And then it says, integers are a subset of rational numbers. I absolutely and totally agree. Okay, let's go to the next item. Now, as I go up, I need to mention something. Notice I didn't touch my calculator. This is just something that you're going to have to know. It's one of those things that in order to be able to manipulate correctly and understand what you're putting in your calculator, you do need to know those basic facts about the properties of the real numbers. Okay? All right, let's look at number 3. All right. Let A represent integers, okay, and set B rational numbers. Okay, that means they represent rational numbers. Which of the following diagrams shows the correct representation of set A and B? Okay. Well, first, we need to really analyze here. Well, if A represents integers, as we said in the prior question, that means A is a subset. Oops, if I can write. A would actually be a subset, and a proper subset, no less, of B. Okay, well, that being the case, let's take a look here. Well, option A, it does show A is a subset of B. Option B shows that. However, C and D show it the other way around. They show B being a subset of A. So I would say C and D are not an option. Now, A represents integers. Okay. So for this option A is -12, which is an integer. And B is supposed to be rational numbers. Well, I absolutely agree with that. I agree with that because all whole numbers can be written as a rational value. Okay, they are over 1, which is a rational. So I agree with A. B, I don't agree because, let's see. Oh, because of A. This is incorrect. This is not an integer. So B does not fit the definition of integers. Okay. All right, let's move on. Number 4, which of the following 10 numbers are irrational? Okay, by definition, irrational is something that is not an integer, and when it's a decimal, it cannot stop, meaning terminate, and it cannot repeat. So, what this leaves us is any decimal that goes on forever in a pattern that is not consistent in any way. Okay? All right, so let's see what we can eliminate. Well, obviously, 0 is an integer, 10's an integer. Now, pi, we know, goes on forever in a non repeating fashion. Now, for negative square root of 80, we need to pop that in the calculator. So, negative second radical. Let's put 80 under the radical. Press enter. Okay, well, that's great, but it still doesn't give us our decimal. So, there you go. And that looks to me like, I know you can't tell exactly from the calculator because you can't see that going on forever. However, we see that if we want it to stop, we're going to have to round. So that also would satisfy the going on forever part. It's not in a pattern that we can determine. Okay, 11%, that stops, okay? And if you're not sure about how this would work, you can just put in 11 second and then open parentheses and just push enter. And obviously that is a decimal that stopped, so that's going to satisfy. Remember we want irrational. Okay, now this 2.5 bar, that means it repeats. So yeah, that's not going to be what we want. We want the ones that do not repeat. Now let's look at this unusual one here. It has 0.61 and then 661 and then 6661. That is a pattern, but it is not a consistent pattern. And because it is not a consistent pattern, we would call that irrational. Okay? Now, let's look at the next one, 20 over 3. So I'll go ahead and put that in as a fraction as 20 over 3. Yes, you could put it in as division, but I like to be a little more precise. Push enter and then your toggle button. That is repeating. So that is rational. Okay, so mark it out. And then obviously, negative 9.34, it stops. So that is rational. Now we have one left, okay? Right, let's put that in the calculator and see what we actually get from that. However, to put that cube in, push your 3 first, then do your second, and see your x radical, push that, and see how the 3 is put where it needs to be, showing that is actually cubic. Now put a fraction under it and 1 over the 27, push our enter, and that's 1/3. And you should already know this. If you don't, just push toggle, that is a repeating 3. Because it's repeating, it is rational. So we have 1, 2, 3 items left. Well, A is eliminated. I see B as something I like. C, nope. And D, no. Those all have rational items. Okay, let's go to number 5. Which of the following 6 numbers are integers? Okay, now when we're asking for integers, we're asking for integers after we simplify. Okay, we have to look at the simplified form. Okay, so let's see here. Which of the following 6 are integers? Well, an integer is not a decimal. Okay, so -7 is obviously an integer. This 0.8%, there is no way that that can be an integer. So let's get rid of that. 15 divided by 5, that's 3. Okay. All right. 15 over 5 is 3. Okay. Now this 11 over 4. Okay. Let's put that in. But as you can see, that's going to be a decimal. And a decimal is not an integer. It is rational, but it's not an integer. So let's mark that one out. Okay. All right. Yeah. And then if you don't, let's go back to this 0.8%. 0.8. And now we have to say it's a percent. So say second, open parentheses, push your enter, and obviously that's a decimal, which is not an integer. Okay. And it's rational, but it's still not an integer. Okay, so we'll leave that marked out. Now, negative square root of 100 is -10. If you're not sure of these things, go ahead and put that 100 under the radical. Anytime you're tired or you don't know, there is no shame in using this calculator. Okay, that is an integer. So we have 3. Let's start eliminate. Oh, actually, I was going to eliminate and keep going, but we can see that this last one can't be an integer because it's a decimal. So we should have 3 only. So we should be able to get down to this. Okay, A's not it. Okay, I'm feeling B again. Let's see. Yeah, this one won't work. C won't work because of the 11 over 4. And D won't work because of the same thing. So again, option B has been verified. Okay, I wanted to thank you guys for watching this video. That was our last question. I really appreciate everyone's support, kind words in the comments, and subscribing and sharing and liking us. Happy testing, everybody.